All right, we're going to conclude Unit 6 by talking about the origin of the universe. And so this is Lesson 5. We're going to do 2 or 3 screencasts and cover the material in Lesson 5, so I want you to listen and follow along. Page 323 is for you to do by yourself, like normal. So let's go to page 324, which looks like this. And let's come down here. All right. What is the universe? Well, we've already talked about what the universe is because it's been mentioned and defined in earlier lessons. But the universe, one more time, is space and all of the matter and energy that's in that space. Okay. So basically, in a nutshell, the universe is everything. It's space, matter, and energy. Okay. And then it goes on to mention, what are the large-scale structures that make up the universe? Well, we've talked about several of them, and we're going to mention them again one more time because we want to make sure that we understand how the universe is organized. Okay? And I'm actually going to go backwards. Okay? The universe is organized into primarily, its primary unit is the galaxy. Okay, so there's potentially billions of galaxies in the universe. Okay, what we have primarily are large clusters of galaxies that are kind of clumped together, and we're going to call those superclusters. Within the superclusters of galaxies, we have smaller clusters, and we're just going to call those galaxy clusters. And then those galaxy clusters are made up of individual galaxies. And remember that a galaxy is millions or billions of stars plus, those clouds of dust and gas. Okay? Within a galaxy, you have many star clusters. Star clusters are groups of stars that are bound together by gravity. And within star clusters, you potentially have many solar systems. A solar system, remember, is just a star or sometimes 2 or 3 stars, and all of the objects that orbit around it. Our particular solar system, with the sun as our star, is only one solar system out of many, many, many. Okay? It's been fairly recently that we've been able to start discovering planets that are orbiting other stars, but solar systems apparently are fairly common. Okay, so if you want to go in the order now that it's mentioned in the paragraph, your large-scale structures, starting with the smallest, is a solar system. Okay, many of those may be grouped together in a star cluster. Many star clusters may be grouped together in a galaxy. Galaxies may be grouped together in small clusters, just called galaxy clusters. And then many small galaxy clusters may be grouped together into superclusters. Okay? But the primary unit that exists in the universe are galaxies. All right, page 325. It says to identify the images below. The images below show a portion of the structure of the universe. Label each image with the correct term on the right. All right. I'm going to start with this one because that looks like Earth with the sun. And so we're going to identify that as part of the solar system, part of our solar system. But remember, our solar system is not the only one out there. Okay. And a reminder one more time is our solar system has only one star in it, and our solar system is located in the Milky Way galaxy, about 25,000 light years from the center of the galaxy. Okay, so that's the solar system. Down here, if you look, here's a nebula and a cluster of stars. So this is going to be a star cluster. This picture, C, is actually like a side-on view of a galaxy. This might be something like the Andromeda Galaxy or the Milky Way Galaxy. Those galaxies are flat, spiral-shaped galaxies, and if you looked at them edge on, this is what they would look like. Okay, so this is a galaxy. And then finally, A shows you a picture with many galaxies all in that picture. So this is going to be a galaxy cluster. Okay. All right. So let's go on to page 326. And we're at Who's Who in the Universe. And they're going to mention some of the scientists that contributed to our current understanding of the universe. Now, please understand that our understanding of how the universe is constructed, how it works, what it's doing, those things, change from time to time as new evidence comes to light. But these guys are all scientists that helped to contribute to our current understanding of the universe and how it works. First, we're going to mention Sir Isaac Newton. You're familiar with Isaac Newton because we've talked about his laws of motion. But he did some other things too, and one of the other laws that he came up with was the law of universal gravitation. And the law of universal gravitation says that every object in the universe attracts every other object. Okay? Anything that has mass is going to attract any other object with mass. But it also states that the force of that attraction depends on the masses of the objects that are involved and how far apart they are. Okay? So this law of universal gravitation explains why objects fall towards the center of the Earth. It explains why planets orbit stars, and it explains why stars are held together in galaxies. It's all about gravity. Okay. Albert Einstein is another scientist worth mentioning. He developed the theory of special relativity. This theory states that space and time are relative. Well, what that means, relative means that when something's relative, it sort of depends on your perspective. Okay, so relative means that space and time depend on the motion of the observer and depends on the object that's being observed. He also developed a new theory of gravity called general relativity, and this theory explains how gravity actually causes space and time to curve. And I know that's like a really wild concept, but there is actually a lot of observational evidence that that is correct. Okay? So, Einstein, special relativity, and general relativity. Page 327. You have Belgian scientist Georges Lemaitre used Einstein's equations to show that the universe is expanding. Okay. Previous to this, we sort of thought that the universe was sort of static, meaning it was not changing. Okay. But Lemaitre explained the relationship between the galaxies, the distance of the galaxies, and the speeds at which those galaxies are moving away from Earth. Okay. He also thought that the universe was expanding and that all matter must have been packed into a very small sort of primeval atom at some point in the past. That's sort of the precursor to our Big Bang theory that we currently have. Okay. Now, he used equations to show that the universe is expanding. Then Edwin Hubble was the first scientist to present observational evidence that the universe is expanding, meaning he looked at galaxies and he observed that most galaxies demonstrated a redshift. Remember redshift from the last lesson? All of your elements have sort of a fingerprint spectrum. that's unique to them. And if those bars are shifted to the red end of the spectrum, that means the wavelengths are a little bit longer than they should be because the object's moving away. If those little bars for that spectrum are shifted towards the blue end of the spectrum, that means that they are shifted towards the shorter wavelength end because they are approaching us. Sorry, I didn't know that my little screensaver came on. Okay, so Edwin Hubble was the first scientist to present observational evidence, okay? Because what he's doing is he's looking at the redshift of those galaxies, and he's noticing that most galaxies were moving away from the Earth. And he noticed that galaxies that are really far away from us are also moving really fast away from us. Okay, so the farther the object was from us, the faster it was moving away from us. Okay, so Edwin Hubble, observational evidence using the redshift, the spectrums of light coming in from the galaxies. Georges Lemaitre used equations to show that the universe was expanding. So they both sort of worked in the same area, but in different ways. Okay, then we have George Gamow, or Gamow, I don't know how to say his last name. He outlined a theory that explained how the elements were formed in the universe. Okay.